Hello viewers, good day to you all. You're welcome to today's class. I remain your pro guide, Aisha Bende. The video is sponsored by Proj Connect. So today we shall continue from where we stopped in the last class where we discussed the rate of reaction. So we have some mathematical problems today which we'll solve. The first one says that we should determine the rate of reaction and also the stoichiometric relationship between the different rates for the reaction. So this is a two-in-one question. The first thing we need to find is the rate of reaction, after which we find the stoichiometric relationship. So the reaction is 2NO2. This is the reactant, okay, which produces 2NO plus O2. So these are the products produced in this question. So now, for us to get this stoichiometric, the rate of reaction, so we have one compound as the reactant and the products, which are two compounds. So now that means we're going to have three rates in this question. That means three rates of reaction. So let's look at the rate one. Okay, for rate one, which is at the reactant. So this is going to be, remember the formula? I stated the formula for rate of reaction, which is the change in the concentration of the reactant or product, all divided by the change in time. So now looking at this, for the first rate of reaction, okay, that's for the reactant. Here we have NO2. So this is going to be, so the rate one is going to be 1 over 2 because here we are having the 2. But here it's going to come into negative, okay, because it's at the reactant side. So it's going to be the change in the concentration of the reactor, which is NO2 all over the change in time. So when we simplify this, this is the same as saying the change, the negative change in the reactant, which is NO2, that is the change in the concentration of the reactant all over the, here we have two change in time because of the two here, okay? So this is the rate one. So now let's move on to the product side. So this, let's calculate for the first product here, which is rate two, okay? That is the rate of reaction of the first product here. So this is going to be 1 over 2 because here we have the coefficient of 2. So since it's at their product, so there's no negative here. So this is going to be change in the concentration of the product, which is NO all over the change in time. Okay. So simplifying this is the same as saying the change in the concentration of the product, which is NO all over 2 multiplied by the change in time. So this is for rate 2. So this rate 1 is the rate of consumption of the reactant. So this is the rate of consumption of reactant. While the second one, which is rate 2, this is the rate of formation of NO since it's at the product, okay? So this rate 2 now is the rate of formation, okay? Because it's the product of NO, okay? So now calculating the last one, which is the second product we have here. So here we have rate 3. So this is equal to, here we're not having a coefficient here, right? This coefficient is just like saying 1, right? So the rate 3, that is the rate of reaction for the second product. So this is going to be rate of formation of O2, okay? So this is going to be the change in the concentration of the product, which is O2, all over the change in time. So this is the product, so this is the rate of formation, okay, the rate of formation of O2, okay. So this is what we have just calculated here. The question has asked us to calculate the rate of the reaction. So these are the three rates of the reaction: rate 1, rate 2, and also rate 3. This now we can now go to the next question, which says that we should now find the stoichiometric relationship between the rates. So the stoichiometric relationship between the three rates is going to be equal to, okay, so it's going to be rate 1 is equal to rate 2 equal to rate 3. That is the rate of reaction of the first one is equal to the rate of reaction of the second one equals to the rate of reaction of the third one, which is the product. So now for us to equate them, so we're just going to take the answers we have here. That gives us the stoichiometric relationship. So here we have minus change in the concentration of the reactant, which is NO2, all over 2 change in time. So this is for rate of reaction 1. So the second one here, which is the change in the concentration of the products, which is NO, all over 2 change in time. Okay, so moving, which is equal to, moving on to the third rate. So this is the change in the concentration of oxygen, O2, which is the product, all over the change in time. So looking at this now, this is the stoichiometric relationship between the three rates. But we have to summarize it when given a question of this nature. There's need for us to summarize it by saying the rate of appearance of NO, that is the rate of appearance of NO, which is the product, is the same as the rate of disappearance of NO2, which is the reactant. As you can see, just as we have here, look, as you can see, this and this. So the rate of appearance of NO, which is this, is the same but double the appearance of O2. After getting all of these rates and also the stoichiometric relationship, every 2 moles of NO2 that decompose, then 2 moles of NO and 1 mole of O2 are produced. Okay, so that means 2 moles of NO and 1 mole of oxygen gas are produced. So therefore, the rate at which NO is produced, that's the first product here, is produced or formed is equal to the rate at which NO2 is consumed. And also, the rate at which O2 is formed is half the rate at which NO2 is consumed. Okay, so that's the summary of the final answer we have. Okay, so that's all we have under the solution for the question 1. So now let's move on to question 2, which says that we should determine the first, which is the disappearance of N2O5. 2, we have to calculate the formation. 2, we have to determine the formation of NO and O2. And 3, we have to find the stoichiometric or determine the stoichiometric relationship of the various rates for the reaction. So the reaction is 2N2O5, which is the reactant, which produces 4NO plus O2. So this is the reaction we are having. So let's begin with the first question, which has asked us to determine the disappearance of N2O5. Okay, so as you can see, the N2O5 is the reactant, right? So we have to look for the disappearance of the reactant. So the rates of disappearance, so we now see that the rate of disappearance, we are still dealing with rates. So the question can come in any form, okay? So now this is saying the rate of disappearance of N2O5 is equal to, remember the formula for rate of reaction is a change in the reactant or change in the concentration of the reactants or products divided by the change in time. So the change in this, so here we have, this is going to be, so since it's the reactant, is going to be minus 1 over 2 change in the concentration of the reactant, which is N2O5, divided by the change in time. So simplifying this is same as saying minus the change in the concentration of the reactant N2O5 divided by 2, the change in time. Okay, so this is the rate of the disappearance of N2O5. Now let's move on to the next question. The second question now is saying that we should find the formation of NO and O2. So let's start with the formation of NO, which is the first product. Okay, so this is going still using the same formula, that is the change in the concentration now of the product divided by the change in time. So here we have the coefficient of 4, right? So since this is on the product side, no negative, so it's going to be 1 over 4, the change in the concentration of the product, which is NO, divided by the change in time. So simplifying this gives us the change in the concentration of NO, okay, all over 4 change in time. What I'm just doing on this step, anytime I'm solving, the second step is just me simplifying, okay? So now we've determined the formation of the first product, which is NO. So now let's get, so this is a two-in-one question. This question is formation of NO and O2, so it's a two-in-one question. So now let's find the formation or determine the formation of the second product, which is oxygen, okay? So this is also on the product. So this is the same formula for rate of reaction. This is equal to the change in the concentration of the product, which is O2 all over the change in time. So this is simplified already. So because here we do not have a coefficient, that is why we have it this way, okay? So now we've calculated the formation of the two products, which is NO and O2 as we have in the reaction. So now the last question now is saying that we should find the stoichiometric relationship between the various rates for the reaction. So as we all know, the stoichiometric relationship is just us equating all the all the rate of reaction we have for both the reactant and also the product. So the stoichiometric relationship, so we know is going to be rate 1 is equal to rate 2 is equals to rate 3. So now our rate 1, we have it as negative change in the reactant, which is N2O5 all over 2 change in time is equal to um the change, okay, the change in the product, which is NO, change in the concentration of the product, which is NO, which you have here, all over 4 change in time, equal to their rate 3, which is for the formation of O2. Here we have it as a change in the concentration of the product, which is O2, okay, all over the change in time. So looking at this now, this is the stoichiometric relationship between the rates that we have, both for the disappearance and also for formation. So as we can see, for the reactants, we have the disappearance, while for the products, we calculate for the formation, okay? So viewers, for our activity for today is a very simple one. After understanding all that we have done here in this question, all I just want you guys to do is to give me a summary of the final answer we have. Please summarize this final answer just as I did in the question one. As I summarized it, look at the reaction and the rate of reaction that has been calculated both for the disappearance and also for the formation, okay? So viewers, if you have any question under this topic or any other topic, kindly bring in your questions and we shall take it up from there. Remember that video is sponsored by Proch Connect, which is on the Play Store. You get educative, exciting, educational videos in College of Education, Polytechnic, and even university. Kindly go to Play Store, search for Proch Connect for you to get started, okay? Thank you for watching. Thank you for your continuous support. I remain your pro guide, Aisha Vende. Bye for now, and God bless you all.